So L'Hopital's rule is used for evaluating limits when you have what's called undetermined form. So for example, if we substitute 0 into this, we'll get 0, 0, 0, and 0. So 0 divided by 0 is undefined or undetermined. So if we got 0 divided by 0 or infinity divided by infinity, you can use L'Hopital's rule, which then says, okay, when you look at the functions themselves at 0, then this ratio doesn't make sense, it's undefined. Well, this one is going to 0, and that one's going to 0, but what about if we looked at how fast they're going to 0? Or in other words, take the derivative of that one, take the derivative of the denominator, and compare their ratio. So we have L'Hopital's rule, and then take the limit as x approaches 0. So take the derivative here, it's going to be 1 minus cosine of x. And for the denominator, take the derivative, it's going to be 1 minus, let's see, the derivative of tangent is secant squared. And then try substituting a 0 again. Well, cosine of 0 is going to be a 1. So this would be a 1 minus 1. And then secant is 1 over cosine, so that would be a 1 again. And so that would be 1 minus 1. So we've still got 0 divided by 0. So do L'Hopital's rule again. So take the derivative of the top, and we're going to get a 0, and then the derivative of cosine is negative sine, so that'll cancel this, making it sine of x. And then for the derivative of the denominator, this will be 0, and then negative 2. From that 2, leave the secant alone at first, and then take the derivative of secant, which is secant times tangent. And then, let's see, tangent of 0 is 0, sine of 0 is 0, so we either need to do L'Hopital's rule again or do some kind of trig identities to clean this up and see how much it is, which is what I'm going to try to do first. So this has sine in it, this has cosine in it, and this has sine and cosine, so I could change this to sines and cosines and then see if any of the sines cancel. So this one is going to be 1 over cosine squared, since there's 2 of them, and then tangent is sine of x over cosine of x. So we have cosine cubed in the denominator, so to get rid of that, multiply by cosine cubed in the numerator. Got to do the same thing on the top and the bottom. And then this has a sine. I'm just going to leave the constant because I want to deal with these trig functions first and simplify that. So divide by sine of x, and then all of these are going to cancel, as well as these will cancel. So after doing a little bit of trig work and algebra, we have just a negative 2 on the bottom and a cosine cubed for the numerator. And we've got it, because now substitute a 0. Cosine is equal to 1 at 0. Cube that, it's still a 1, so we get 1 over negative 2. So negative 1/2. And then I want to take a look at the graph and verify. So there's the original problem, x minus sine of x over x minus tangent of x. Change the window to be close to x equals 0, so negative 2 to 2 should do it. And there goes the function, and at x equals 0, it went down to negative 1/2. So if you actually plug in the 0, it says there's a hole in the graph. But that doesn't matter. We're talking about what if you're really close to x equals 0. Negative 1/2.